We'll continue with our geography series, and today we are talking about pressure gradients in the atmosphere. So what is pressure gradient? Pressure gradient means how a balance of pressure happens on the Earth's atmosphere between high pressure and low pressure. So today we'll talk about low pressure and high pressure areas and what happens when an area, how an area becomes low pressure first of all, and what happens to the air masses which is around and what is the movement of air. Respectively, we'll also talk about high pressure areas and what happens in an area where how an area first of all become a high pressure area and how the movement of air happens in a high pressure area also we'll see. So first we'll see about low pressure areas. This is sun, okay, and if this is a part of earth, okay, if from sun rays are falling directly on the respective part where we are studying now, it will be like this, direct rays from sun. So the area where the direct fall of sun rays happen, that area become heated up. So there will be a development of low pressure area. How an area become low pressure? If the density of particles in that area is very light or the particles of that air mass is loosely packed, we can say it is low pressure. Because of high temperature, these particles will expand and start rising up. So low pressure area is developed in that kind of areas. Okay. So if a particular area is low pressure, the particles situated in that area, because of the sun rays, the particles will heat it up and it will start moving or rising towards the top of the atmosphere. So we say that this is, if this is atmosphere, this is troposphere. Everything happens in troposphere. We know that troposphere is there from 0 to 8 to 18 kilometers. In the equatorial region, it is 18 kilometers. Towards the mid latitude, it is 13 kilometers. Towards the polar regions, the length of troposphere is 8 kilometers. So in troposphere only, this significance of low pressure and high pressure majorly happens. So this is Earth's atmosphere, and if there is direct fall of sun rays like this, okay, a sun rays fall like this area will become heated up, okay, and particles from this area will started moving up. You can see that particles are moving up. As the particles started moving up, what we observe is that because of particles are lightly packed here, it will start moving up, and as soon as it reaches the tropopause, it will hit there. Okay, so we can see that we'll see in the next discussion. So please understand this one. Light solar rays are falling on the Earth's surface. The specific area is getting heated up. Particles in that area is loosely packed because of the rising of air. So this area rising or ascending of air happens. So what happens here is rising or ascending of air happens. So since that area is hot, the air started moving up and rising or ascending of air happens. Now in the same area, sides we know. From sides, particles started moving towards the low pressure area. Why? Because in both the sides comparatively the pressure is high there. So entire area was same pressure. Suppose it was same pressure, light rays fall here, this area become hot, air started moving up. So what is the pressure of these two sides? Comparatively high pressure. So the waves or the wind from the high pressure area converging towards the low pressure area. So low pressure area is characterized by two different things: rising or ascending air and converging air. This is called converging air. So we can say very precisely that where high temperature is there, HT means high temperature, where high temperature is there, that will give an effect of low pressure. We know how low pressure comes. From low pressure we can give it is rising of air, or we can talk about ascending of air, and this will also result for convergence of air, converging air. Okay, this is all the characteristics of low pressure. Now we will try to understand what happened in an area where high pressure is there. Sun, earth. Okay, so please understand which all places are we observing mainly high pressure. Okay, one chance is there where light is not falling, and other multiple factors are that contribute for a place to become high pressure. So one factor we'll take is that sun rays are not falling directly on the surface, or this is delineating to some other place or diverging to some other place. When this happens, what we understand is that the area where there is no direct sunlight, we can consider that area as cold area. All that area is cool, we can say. Therefore, cool air will be there. where there is no direct sunlight. The area where cool air presides, we can say that that area is denser. So difference between hot air and cold air, can you please understand? In hot air, what happens is that particles are loosely packed and rising of particles happen. In cold air, what happens is that particles are densely packed or compressed into the air mass column, and particles will start moving down or descending of air happens. Why? Because of density matters. Because cold air is heavy, it wanted to subside or settle down, and hot air always want to move up because it is lighter. We have spoken about the evolution of atmosphere. We said that towards the center of the atmosphere or towards the center of the Earth's center, because of gravitational pull, we always absorb particles which are heavier towards the center, and particles which are lighter will always move towards the periphery of the atmosphere. Same like here. Warm air which is hot is denser, density is very less, it will move towards up, and cold air which is very cold or density is very high, it will try to subside or cool down towards surface of the earth. So high pressure area where the cold air is there. When cold air is there, as we discussed, it always wanted to settle down. Okay, so it will start coming down. The process of settling down of cold air or the process of air mass column coming down is called descending of air. Okay, descending of air happens as soon as air will touch the earth's surface. We know surface is opaque. Can it go deep inside the earth? No. So what will it will diverge. It will move like this. So it will diverge. And this process is called the divergence. So this is become high pressure area, low temperature. Okay. Now we'll have a quick recap on what we discussed about low pressure and high pressure, and then we'll move towards the stability and instability of the atmospheric pressure. So first one, low pressure, we spoke about here. Low pressure area is an area where sun's rays fall directly on the atmosphere. That area or that particles will become heated up. As soon as it gets heated up, this particles start moving up, which is called rising or the ascending air, and the sides will be having comparatively high pressure. So these particles will try to move towards the low pressure area. There is convergence of air happens, rising or the ascending of air happens. What happens in high pressure area? High pressure area will be noted by cool air or the cold climate, where particles would like to descend towards the surface of the earth or to some place. So descending of air happens, or downward movement of air happens in high pressure area, and as soon as it reaches the earth's surface, since it can't go inside deep inside the earth, it will start moving towards the sides. It is called divergence of air happens. So low temperature will give high pressure, will give descending of air, that gives divergence of air. So low pressure area, high temperature, ascending of air or convergence of air. High pressure area, less temperature, descending of air or divergence of air. So this is with regards to low pressure and high pressure areas. Now let us understand what is the stability and the unstable condition with respect to atmosphere. Suppose we have warm air here, and above the air column we have cool air. So what will happen in a situation like this? Convection happens, or the vertical or the upward circulatory movement of air happens. So like this it happens. The air will start moving like this. That is, as soon as towards the surface of the earth particles become warm, it will start moving towards the top. So the cold air will come and subside down. Again that particles will become warm. So the cycle continues. This is called convection, and this area or this phenomena is, we say it as unstable phenomena. This is unstable. Why? Because unstable, because heavier particles is on top, lighter particles on almost near the earth's surface. So instability occurs, where every time this denser particles will try to come down and settle, whereas warmer particles are also not permanent, they also want to move towards circulatory motion, and the entire phenomena is unstable, or unstable atmospheric condition exists. Now let's take another situation where cool air or the cold air is down and warm air is on top. So what is stability ratio here? More stable, because cold air will subside towards down and warm air is on top. It's almost like a stable area. So this condition is stable. Now as soon as this happens, there is cold air here, so there is no current rays of sun's rays coming, so particles will not try to move up fast, but there will be effect of other factors, and this will obviously move towards on later stage, but currently this stage is stable stage. So what is the difference between stable and unstable atmospheric conditions? Unstable atmospheric condition happens when there is warm air on down and cool air on top. There is convection happens, up vertical and upward movement of air happens, that is called unstable condition. Stable condition is where cool air on down and warm air on top. When cool air is down, there is almost like a stable, that means denser particles are down, everything is settled, and lighter particles are on periphery, that is also settled. So like a stability in the atmosphere happens, that is called a stable atmospheric condition. Now we understand that pressure always move from high pressure to low pressure. Okay. So entire atmosphere or entire globe, what happens is that always nature try to balance between high pressure and the low pressure. So pressure gradient also work in this way. Wherever high pressure is there, it will always tend to move towards low pressure, and where low pressure is there, it will always tend to move towards an area where high pressure particles will come and they will balance this area. That's all for today. Hope this helps. Thank you.